Alrighty everyone, welcome to Advent of Code, Day 8. A few seconds here until the puzzle starts. Here's hoping today's goes not too badly. Yesterday wasn't that bad at all, so who knows though, we're getting to the days where things might get a little difficult. Alright, let's get into today's puzzle. The expedition comes across a particular patch of tall trees that are all planted carefully in a grid. The elves explain that the previous expedition planted those trees as a reforestation effort. Now they're curious if this would be a good location for a tree house. Determine whether or not there's enough tree coverage here to keep the tree house hidden. To do this, you need to count the number of trees that are visible from outside the grid. We're looking directly along a row or column. I already launched a quadcopter to generate a map with each height of each tree. Single digits, okay, it's the height. Tree is visible if all of the other trees between it and the edge of the grid are shorter than it. Only consider trees in the same row or column. That is, only look up, down, left, or right from a given tree. Yes, all the trees around the edge of the grid are visible since they are already on the edge. There are no trees to block the view. This example, these interior 9 trees. The top left, okay, this is just getting to visible, not visible. It makes sense. With 16 trees visible on the edge and another 5 visible in the interior, a total of 21 trees are visible in this arrangement. How many trees are visible from outside of the grid? That's a big chart. Okay. So figure out if these are visible or not visible. Take this back. One more time, restarting. One more time restarting. We have our grid we've initialized. Okay. We'll just go through each direction. For int I equals 0. I is less than input size. So this is going to be going up and down. We'll go the directions left and right. So we need int left tall, int right tall, and then for we actually do this in one go. For int j, this is actually made a row. I should do this row and column. Column equals 0, while column is less than s dot length, column plus plus. What we'll do here is we'll do a check now of s dot, we'll need the int, our column is going to be equal to s dot length minus column plus 1. So if s dot char at, actually I should do this as chars. If the char at column is greater than the left tall, visible, add new point row column. Oops. Right column is greater than right tall. Go ahead, add it. And then last but not least, S0. So this is going to be now column, S dot length. Don't need that. So now this is going to be top tall and bottom tall. Row is 0. Row is less than input size. Oh, we need to update these though. Hold on. We need to do then left tall equals that. That way they get updated. So if char at string s2 equals, whoops, Do I need grid? technically I didn't need to do grid here. I'm kind of doing this without using grid, so that's fine. S2 input dot get row. S2 char at column is greater than top tall. Top tall equals this. This is gonna be this is not that, it's just changing S2 to be input.size minus row plus 1. And again, S2 char at column greater than bot tall. This is row. We should do row T. This would be helpful to have row T here, because row T, and this is just column. And then don't forget to update bot tall. And then if I did this all correctly, it's this. Now if I did this all correctly, we should get 21. Or we get an error. Because I didn't change this to be row. Look at that, we get 21. Why didn't I just do this from the start? This is so much easier. It's so much easier. So much easier. I had to read that wrong. Alright, so content with the amount of tree cover available, the elves just need to know the best spot to build their tree house. They would like to be able to see a lot of trees, measure the viewing distance from a given tree, look up, down, left, right from that tree, stop if you reach an edge or at the first tree that is the same height or taller than the tree under consideration. If a tree is right on the edge, at least one of its viewing distances will all oh. All of that, and I still need my grid. I need my grid back. Because we have to now go... I'm rewriting this again, chat. Or I'm saying chat, but we're rewriting this again. I hate this. This is I've redone this so many times. I don't. All right. We're redoing this now again. String s equals inputs get 0. You'll see what I'm doing here in a second when I get this grid back. Map point char character grid put row column. Sorry, as the train goes by here. So build a grid up here. So now we need a method here, public boolean can see edge. This is not JavaScript. I can be private. And so what this is going to do is it's going to have to take in the grid. It's going to take in a point. And what this is going to have to do is go through all directions. So for int I equals p dot column, while I is greater than 0, I minus minus. So what's going to happen here is we're just going to do grid get new point p dot row I. So we're actually start -1, and we're going to do if this is greater than point char. If it is Boolean can see true. If it is greater than or equal to point char, we do can see equals false and break. If can see, return true. Otherwise, on to the next direction. We got to do this 4 times. So now we'll go +1 while I is less than I need to have a variable here that has a width. Width equals inputs get 0 dot length. I need a nice width and height variable, that way I can access it from this method. There we go. Okay. So can't see edge, so there's one direction done. The second direction, while I is less than width, needs to be static. Actually, it doesn't need to be static. This doesn't need to be static. I is greater, or I is less than width, ++, same thing. On to the next direction, which is now going to be row. Actually, we should just do is copy this. This is row. This is I, and this is going to be p dot column. Return can't see. This is row height I p dot column. And now we can do get rid of that for point p in grid dot keyset. Now we can just run this can see edge method here. Pass it the grid, pass it p, and pass it grid dot get p. And in theory, if I did this correctly, we should get 1560 again, no problem. Or not. I think I'm missing the edges. If p dot row equals 0, p dot column equals height. No, column is width. This is height. Is this correct? No. Why am I missing something? Equal to 0. No, say shouldn't miss it. Should get it just fine. Can't see. If grid get point row I. It's great. Not equal. Wait, no, yeah, equals right. Yeah. What did I mess up here? I feel like I shouldn't have messed this up. This should be right. Could get that point. Because that needs to be row. There we go. Good job, me. Alright, so now part 2 is go through. We need to find the score. The sneak score is fine. Multiplying together, it's viewing distance. So we need to count the number. Okay, so get... so we need to take this. When we take this, we need to update it. So this is going to be a int array, actually. And this is going to be viewDist. It's going to be in 4 directions. I just don't want to do this twice is what I'm getting at, but public record view data int oops view distance, and then we're gonna go with this. And so what's going to happen is let's see. I still want this view distance here. And so this view distance is 0. All it is p dot row minus I. 1 I minus p dot row. This one is p dot column, and I minus p dot column. So there's the view distance, and then the can see bit. Because basically I don't want to change it to false. What we can do is we can just do this. We're just gonna do this because I am lazy. So for int I equals 0, while I is less than can see length I plus plus, can see I equals true. Oh, you can just do a fill. That works too. So yeah, so now this becomes can see whatever. 1 1. Oh, I didn't change these. 2 2 3 3. And then we just can do can see bool. I'm gonna do for int I equals 0, while I is less than can see dot length I plus plus c equals c or can see I. What does this change to? Ah. And we can return view data now. And this is just visible. And then now for part 2. Long, largest. Go through all of these. And actually we can do this here. We can keep track of it here. We don't need to do this separately. Lap largest equals 0. And all that largest is, this is going to be view data, can see. If it's visible, we can add it to there. Otherwise, long product is going to be 0, and then for what was it? Int I in view data, view dist, prod. It's multiplication, right? I think. In which case it should be 1. Today's been kind of a disaster. Multiple, yeah, product. And then quick check. If prod is greater than largest equals prod. We're gonna get there in the end, but today's not been ideal, and I didn't get it right. 8. We should get 8 from this. We get 9. How do I get 9? How do I get 9? This needs to be like 2 string, yeah, okay. Dang negative numbers. What's negative? Oh, wait, why are they negative? What? How am I getting why am I getting negative numbers? What? How am I getting negative numbers? I'm getting negative and positive. That makes no sense. Oh, because these are all backwards. That's what's happening. That's what's happening. Now we get 3. Nice. And then what's the largest one? Should be 2, 2, 1, 2. I don't have any 2, 2, 1, 2s. Although I shouldn't have any zeros. The fact I have zeros is not right. Because I should be at least seeing 1. Oh. Can I do this? Looking up, its view is not blocked. I could see 1 tree. This day has just been disaster. Today has not been good. Today, okay, so what is this one? It's 1, 2. One, 1, 1, 2. It must be the fact it doesn't see, it goes off of the, okay. Okay, so we actually need to fill this in differently. 4 y is less than. We need to kind of like initialize this as in, or actually we don't have to do it there. We can do it here. If it can see, then we just do, in this case, -1, so it's going to be there. So we can just do that. This one's a bit different because it's going to be with minus that. This one is just this. Height, P row. I think that's what we're missing. Nope. Fine, 1, 2 again. One, 3, 1. Okay, so it must be too many. One too many? Hey! We got the answer that's right. I don't know if my logic's correct. But I'm just kind of, yeah, yeah. We get that as a number. Is that our answer? It is, we're done. An hour 13 minutes, an hour 12 minutes later. Huh. Yeah. So, I did this, yeah, so I've edited probably a good chunk of this. I definitely did the first bit wrong a few times. Like, I knew what I wanted to do, I couldn't think of the right way to do it. This is still ugly. But I guess. At any rate, let me explain at least what my solution is doing at a high level here. I won't be going in depth because it's just not that great. But at a high level, we're given this grid with basically we're given a height map essentially. And with this height map, we need to know if a certain point can see the edge of the grid. It can see the edge if the trees between it and the edge in one of the four cardinal directions, up, down, left, right, if all the trees there are shorter than it. To do this, we first take our input and just dump it into a grid, basically going through all the rows, all the columns, make it to a grid, save it there, and then we basically go through every point one at a time, and we call this can see edge method. This can see edge method does two things for us. It gets whether or not a point can see the edge in each direction, and then from that, all right, well, it just gets if we can see the edge from that point, as well as how many trees it can see from its point. It does this by starting at its point and then going in all four directions and just seeing if it can see the edge, and then also measuring how many trees it can see in that direction. That's all we're doing here. It's not the prettiest, but this is all this is doing. It's just going each four directions individually and testing it can see, and then it's then condensing all of the can see booleans into one. And if any of them can see the edge, then this tree can see the edge. And then from the data we get back from this method, we just go into first see if this tree is visible from the edge. If it is, just add it to a current, I have a set, this could be a list though, just add it to a list of visible trees that then gets outputted for the part one. And then we then multiply all of the view distances from the tree in all four directions, and then save that. Keep track of the largest one we found, and I'll put that for part two. And it's not a hard problem to understand. It's just a hard problem to figure out what the right or the best way to go about programming this is. And I just tried a bunch of different ways, and they just didn't work out good enough to where I wanted it to. And I probably should have stuck with one of them, but I didn't. But in the end, at least I got a solution that works and is okay in terms of the prettiness, I guess. But again, not a hard problem to understand, just a hard problem to figure out how to code it. So this day was kind of a wash for me, but anyways, hope you guys enjoyed. I'll see you tomorrow for day 9. Peace out.